Hello Earth, welcome to the sixth episode of Making Cell, a series of videos where I record myself developing, designing and developing a programming language and environment called Cell. So if you really want to understand what this is about, I recommend you just jump into the first video of them all and then just perhaps pick up the thread from there. So I'm gonna basically pick up where I left off, which is yesterday. I was trying to bootstrap a very basic version of Cell in JavaScript, and we were starting to make some progress by looking at the basically some test cases here. So, for example, some valid instances where I'm performing a get operation, some valid instances for when I perform a put operation. Actually, not an operation; it's a valid get call. Because remember, our little Bible is this thing called the Organization of Digital Information Systems. This is all open source, by the way. You can always go and check it out. And basically, this gives us the backbone for the entire approach of Cell. So yesterday we had these good test cases. I could actually call it a valid get call because that's a better way to name it. And I'm going to be doing a lot of this until we develop, hopefully together, an editor that does this for me. In the meantime, we're just going to do it manually, but we're going to keep it in order. And by the way, these equal signs go here. Sorry, my bad. So these are a good set of test cases for get. They're all a single line, as I said here. So we're going to have this valid put calls. Sorry, I'm a bit tired apparently, but hopefully I just get into the groove very soon. So valid put calls. Put calls are the ones that, by the way, I should not be doing this here. I should do this on the notes of episode 6. So I'm just gonna shamelessly copy this stuff and then say, for now, let's just go with single line. So we're going to single line what? Single line calls. So we have this here. We have a set of valid put calls. And now we're going to start defining a valid put call. For example, if you do something like the message would be just checking something. Yeah. So have message. For example, it has to start with add and put. No way around it. Otherwise, I don't know if it's a put or not. Earlier, before I started this series of videos, I was thinking that perhaps we should have something like import, where add is a get and exclamation mark is a put. But I actually like the idea of put being a call that has a definition, and I don't think that put is quite as let's say fundamental as get is, because yeah, I think get really is the essence of what a call is, or what reference really is, and whereas put is slightly less fundamental. So I think put could almost be defined as a userland quote unquote call, and kind of follow the rules of other calls. So, and also this has the added advantage of less syntax, right? Everything's a call. The default call, so to speak, is a get, but there can be other calls. So we're going to basically make put a normal call. Well, as normal as it can get, because we need it really to be built from the ground up, which is what we're doing right now. So it has to start with add. The text that we get that we're going to parse into a call has to start with an add, be followed by put, and then it has to be, well, let's actually go with the corner cases. If we don't get put anything there, what happens? Let's see. What I could do is it deletes the whole thing. That's a good way to reset everything. Here's gets get the whole thing, delete the whole thing. So here we can have a delete for free, almost, right? Because that deletes the whole thing, because you don't pass any extra arguments or data to that call. And let's say we have a second instance of this, which could be put foo, and I don't pass anything else, and it just, what it does is delete foo, whatever is in foo. So if you had foo equals bar, or foo pointing to bar, then suddenly after this foo is nothing. If you get foo, then you will get an empty string. Sorry, an empty text terminology. So yeah, this is we are getting the delete for free. How nice is that? And by for free I mean within the same call. So if we have a more, let's say, normal quote unquote put, it would be foo bar, something like this, and it says set foo to bar. And this setting of foo to bar really, how can I explain it? Is, I think, better, I would say, and feel free to come in after me with a pitchfork in the comments, but like in a normal programming language you would do something like foo equals bar, right? So in this case, if you do something like put foo bar, you're saying the same thing, right? Let's say. But here, with this approach, you could also do something like put foo bar 3, and what this would do, it would be something like foo equals bar 3. That would be in JavaScript, right? It's a much more dynamic way of looking at data based on what I call paths, and this is in the little Bible in Todis. That's part of what I call pillar 2, which is the data space. The data space is basically made of data paths, which define lists and hashes, and within it they have text and number, because every single, let's say, element of a path is either text or a number, as for example in this case, text, number. So it's more dynamic, really. So it's not just setting a top level variable. You could just set something very specific. And I am really excited if I ever am able to bootstrap this set of fragments into a rocket. I'm really excited to see what it would be to actually be able to program like this. I'm really excited about it. So that's one of the things that is pulling me. So we have this. I'm going back to the script. I think, look, I wasn't planning on this, but it's pretty neat. We have 3 invalid cases, 3 valid get calls, and then 3 valid put calls. I think this is more than enough. So let's just set aside our, I don't know, sense of taste, and not even, I'll say, conventionalism, and try to implement it in JavaScript, just like that. Okay, if I'm implementing it in JavaScript, I would like to have some syntax highlighting, right? I guess I could have some syntax highlighting. Maybe I don't need it. Let's see how wrong I am. So I had some code earlier that I'm going to copy. Was it 3? Was it episode 4? Yeah, here. So let's just see how much code we need to get this going. So we're going to basically define a function called make call. Actually, you're not making a call. You're receiving a call, right? Yeah. I think, I don't remember what terminology. You might think, why the hell do you care about this? Are you not just postponing the writing of the code? And I would say, no, not really. I'm quite confusion in that notion that proper naming comes before everything else. Like the proper name brings the proper sequence and unfolding to everything that has a proper name. So it pays to think these things through. Like, for example, for me to understand a lot of diverse things like function, process, program, logic. To understand it all as a call and be able to explain it all as a call was to me mentally it feels like a breakthrough. I can understand programming much better after I came to that conclusion. I still use that realization every day, and it doesn't deceive. So in a lesser way, perhaps I just want to be able to find a good word to say someone is making a call, and then someone is receiving a call. I guess receive is the best term. I wonder how much I use it here. Receive, yeah, receive. There's 13 mentions of receive in this document. Yeah, inside the receiver of a call. So I think I never really defined that. I just say, oh yes, the receiver. In communication, which by the way, this thing represents computation as communication. The idea is, yeah, that sorry, not the idea. Saying that you're receiving something is that you receive a message or you receive a call. So yeah, the receiver. I wonder in Shannon's theory of communication, Shannon's theory. Just let me quickly to see if there's something else, some other word used. Shannon Matthews, no. Shannon of communication, information, sorry. Where's that tip, like a classical schema of Shannon? Where's it here? Where's this one? Yeah, the receiver. That's what I'm looking for. Although I'm not calling this a transmitter, I'm calling it the caller and then the receiver. So the caller makes a call and then the receiver receives the call. Yeah. Okay. Yeah, this is our basis. By the way, I put Shannon at the top of this thing because I felt it was the guy to put there at the top in what he was conveying. So anyway, all of this to say that we're just going to say here the function is going to be called receive, which might not be a bad name to call this in general when I later, let's say, do a more cell powered implementation of cell. So receive. Sure, let's do receive. It gets a message by definition, and then we're just going to go and get the data space, the entire data space. No concern for efficiency. It's 2025 and everything's really fast, but at least this type of thing. So if there's no data space, we just initialize it to empty text, so we're always dealing with text. And then, so that was step 1. Where did I have the list of things I had to do? Yeah, let's just copy this over. By the way, I'm listening to music, but I cannot play it because I might run into copyright infringement. So what you can do is play it along while you listen to me. Highly recommend you do if you are into this kind of music. Just post the what it is in the description of the video. So okay, we received the message. All right, we parse it into either a get or put call. So we basically need to validate the message. So we can just validate the message. So we can say, we can call a function called validate. So let's just assume the function is defined already. Var parsed message. Actually, rather than calling validate, what we can do is have a function that parses the message. And if the message is not valid, we get an error. And an error is a value. That's also part of TODIS, the treatise. So, and if it's a valid message, we get the message. End of story. So, the parse message is what? is a a call of parse. And then we can say something like if parsed message error. We can assume that parse message is always going to be something in terms of JavaScript. It's not going to be a null value. So if there's an error, what do? We can do a classic here. Let's start with this. We can just put an alert and just pretend like it's 1997 and this is a cutting edge interface development for the web. So like when we were submitting forms, then we can improve it. But this will basically do two things: let the user know, and in the alert, and then a return that basically stops with any further actions. And then we can just do something like if parsed message get, we can assume they would return perhaps an object of the form get whatever. Then in that case we can assume that then we have a function called get that does get parse message get. This assumes that the message has only one, let's say, destination, which will be get or put, and that's exactly what it should be. And if parse message is put, we do put parse message put. I'm starting to think we really don't need the data space here at all. That should be part of the get and put functions. So we kind of have it here. And by the way, I could also write something like this. Actually, no, I could not. If get and put are top level variables in JavaScript, I cannot just definitely not in ES5 JavaScript. I cannot do something like get me whatever is there, the single key inside parse message. I mean, that you can do, like, is it get, is it put, and then call that thing. You could only do that if you were putting get or put inside a common object. Like if you did, for example, like I don't know, var helpers equals get, and then you would have put, and you would just put them in an object. Then you could do something like var I don't know, destination of the call. It would be object give me the keys of parsed message, the first one, because there cannot be two. We're going with multi-line for now. So in that case you would then do something like helpers and use the bracket notation, this destination, destination, of course, and then you would say I just invoke this and pass the parsed message destination. This is perfectly valid, and the only thing stopping us from doing this is, well, perhaps readability, although I hesitate to say that because it actually might be more readable to understand it like that, especially if you have many and not just one. But besides the readability, it's also the fact that not besides, rather than the readability issue is that the top level variables cannot be accessed through bracket notation, which is something that we will definitely be able to do routinely in this thing in Cell. So remember that one. It might be a bit trickier to implement perhaps, but we can definitely do it. So I'm really looking forward to that. That's a limitation that we have in JavaScript that forces me always to be structuring a lot of functions, which are going now to be called calls, into an object. And now, well, now not yet, soon we won't need to do that. We can just put it at the top level and still call it dynamically. Anyway, back in JavaScript, we are going to remove that and then just do it like this. So we have get and put, and really I guess we need to get a result out of this and just put it somewhere. So that put it somewhere. Where are we going to put it? Okay, let's not just dwell too much on this. We can just set a variable result. By the way, if you're wondering why I'm not using constant or let, I honestly don't care about that distinction. Definitely even less in this context. So I'd rather have one way of initializing variables instead of three. So if parse message is this, then result equals that, the get. And if it's a put, result equals the invocation to put, and then I return the result. End of story. Yeah, so now I need to define three functions. I need to define parse, which takes a message, which is text. I need to define get, which takes a path, really. And I need to define put that takes, I guess, a message. I guess we can say that all three take a message to keep it more simple, because then I have to say put gets a path and also a value, and just fuck it. Let's just say it's all a message, and then you just interpret that message as you want to interpret it, because that's your attribution as a receiver. That's a nice way to put it. As a receiver, you have the attribution of interpreting the message that you get any way you see fit. So you're going to get some bits which you can then apply transformations to, and that actually, funnily enough, is also calls that you make from within the receiver to interpret that data. And then once you get, let's say, larger building blocks like characters, then you also interpret that data any way you see fit, and you produce a response. It's pretty cool when you think of it like that, because it really, it's if the message is information that is coming into the receiver itself can also be defined in terms of information. That's the interesting thing. But that information takes that other information and produces a third unit of information, which is the response itself. Yeah, the overall picture to me is works. So let's just keep on betting on this intuition. So in both cases, let's just define parse and be done with it. So we had these use cases, so we can already start saying that I think we need to make another simplifying assumption, because I wonder how far I can get without proper parsing. I just want to use regular expressions for now, because I really want to see something working on my screen. So we have an issue perhaps with quotes. If we get rid of, let's do this, simplifying assumptions. One is single line messages, no calls. And then the second one is no quotes. Let's go with that one for now, because to parse quotes might be tricky, because they have spaces inside them. That's what you use quotes for. So let's just assume there's no quotes, and let's go with that. So what I would do is, I would expect already the message to be text, so I'm not going to perform any validation on that, and I would just split the message on any white space. I'm writing a regular expression here, and I wonder because what I want to do is that contiguous chunks of white space we treat it as just one white space. For example, if I do I'm running now the anode runtime, right? So if I just do something like a space 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 b split, and I just do one space here, yeah, I need to basically make the regular expression greedy, which is much as you can. No, that didn't work anyway. Maybe I have to do one or more with the plus quantifier. Yeah, that will do the trick. That basically takes contiguous chunks of space and lumps them into one. Good, good. Okay, this is what we want. And if you have something like tab space, sorry, tab space b, yeah, same result. Good. I like this. And if we have stuff at the beginning, at the end, space at the beginning, at the end, yeah, we also need to trim this sucker as well. The trim does that. So trim and split. I might miss a bit this fluent style. I'm taking all sorts of detours. I hope not only that you can apologize, not apologize, you can forgive me, but also that you actually enjoy the detours, because I'm gonna take a lot of them, because ideas beget ideas. So I wonder how the hell would I ever write this in cell afterwards, and I figure I could write it something like this, because this is very convenient, right? You have the string, then you call trim, and then you get the result of that, and then you call split with an argument, and you get the list. That fluent style, I have to say, is probably the best thing I've seen coming out of anything remotely object oriented. Reminds me a lot as well of the Unix style of just having a what do you call it, a linear yeah, basically one command being piped to the next one, like a linear sequence of things where the output of one call, really, because they're calls, serves as the input or one of the inputs of the next call. And that's really cool, except that both in JavaScript and in Unix you have delimiters, and in Cell we're much more limited with the delimiters. We are usually not using parentheses to delimit anything, parentheses or what do you call it, or curly braces or square brackets. That's what I was looking for. So how would I write this? I would do something like, I need to do it the other way around, right? The call goes first, so I would just basically first split by, I have no idea what the regular expression syntax I'm going to use. This actually is a good, I don't know, it's more fun to do this than what I'm supposed to be doing, right? I guess this is a very common, it's a human universal. But so let's just say I'm writing this as a regex for now. I have actually, I think, a better or worse idea, but definitely not the same way that it's normally done. So I pass the regex there, I split by, and what do I split? What do I split? I split something that I trim, and the something that I trim is so I had to do it in 2 lines instead of 1. I still think it's relatively fluent. I kind of like it. I mean, someone has to like it, right? If it's not me that I'm designing it, who else? Okay, so there might be something to this. Cool. Where were we? Yes, back in the real world, I need to trim and split in the right order. So I'm just gonna do message. First trim, then I split. If you, sorry, I keep on going back to the previous example. If you wanted to apply the operations in order, you could do something like, you would trim something in place, then you would do, that's the first step of the recipe, and the second step is to split this thing, like you would split whatever came off at 1, so you could reference the previous step. So that's how you would do it more linearly instead of nesting it. So actually I could actually write this. So you first split and then you trim what happened in step 1. Yeah, I fully intend this thing that you're looking at right here to be computable, to be executable. I'm already able to execute it in my head, and I don't think it's too hard. I might be missing a couple of things, but this is tenable. So this is what cell code would look like. And I see and I dream a possibility of basically everyone being able to define their own words and using good conventions for them. And if someone is a decent writer, the words that they use will make sense to you, so you will be able to read the code quite well, because let's say the data format and it's not the data format, the first of all we use only 4 types, and second, the way that those 4 types are expressed in text is done in a very uniform way. So really what's the syntax, let's say the feel of the syntax is always going to be the same for everyone, but at the same time you'll be able to define very basic things, like if you want to define the way that you, I don't know, split text into a list, you can define your own method with your own name, and the name is not just for the actual call but for the message. So if the message is a hash, then by and what, you might put other names. So decent writers will pick good terms for these things, and meaning will be conveyed. And to me, that's way more exciting than any benevolent or malevolent dictator like myself who defined the language years before, saying this is the way that you actually split a string. I'm really intrigued by that. Either that or I'm really procrastinating on the code. So I have the message. I reuse the message variable I had from above. I trim and split by white space. So now I have a list, which in JavaScript is still called an array, although it can contain things of different types, unlike arrays in previous languages. So what do I do with this? If the first element, what was our list of invalid thingies? The call must start with, why double add here? This is just wrong. So the call must start with add and have a space after it. So I guess what I'm really trying to say here is that the whole thing has the first element of the list. Now that I have split it and trimmed it, if message 0 is not a text with 1 character, which is add, return error, call must start with add. Actually, we can do it even better. If the message has no length, return error, message is empty. Although we could get philosophical and say an empty message should have some sort of valid, perhaps empty response. But you know what? No. Like, why did you make the call in the first place? It's probably that you forgot to send it out. I think in that particular case, common sense can prevail. So, and by the way, I forgot. Message length is 0. Good. Okay, now we have a message of non-zero length. So message 0, we know it has to be a list of a text. If it doesn't have a, like we did above, if it doesn't start with an add, call must start with an add. Here's something nice from JavaScript that I'm going to miss a bit in Cell, which is you have two sets of quotes, single quotes and double quotes, and you can be smart about when you use when, and then you just intercalate the other ones. Whereas in Cell, we're going to be using double quotes for everything. A single quote won't have a, well, I guess if I am using double quotes to delimit text with spaces, if I'm sending error message back, I can always use single quotes. Yeah, but I want to be consistent in the naming, so no, I will be using double quotes for everything. So I have to escape my double quotes inside the text. For now, let's just use the niceties of JavaScript while we have them before we leave them behind. So we have that error message, and now, sorry, it's not the first message. If the first character of the first message is not an at, we say it has to start with an at. And if the first element itself is not an at, means it's probably the add has some other stuff after it. I'm gonna say here. What was the error message? Call must start with add and have a space after it. But look how lenient we are. That doesn't sound like too much, right? Like even for me, my anarchistic tendencies, it still sounds pretty free to me. All right. So, just a minute.